Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Exercise 6.10. Number 1. Given that x is from 0 to 360 degrees, find all the values of x that satisfy each of the following equations. A. Sine 2x equals to negative 0.4321. Right? So the first step, we find the reference angle for 2x. So we press arc sine of 0.4321 and we get 25.60 degree. Then we put our reference angle into the quadrant so that the sine will get negative. So only T and C, which is quadrant 3 and 4, sine will be negative. So we put our 25.6 in quadrant 3 and quadrant 4. There, because of the angles of 2x, we need to get the domain for 2x. So, from the domain of x from 0 to 360 degrees, 2 times of x will be 2 times of 0 to 2 times of 360 degrees, which is 720. So, we know the 2x will be, first one, starting from the positive x-axis, turning anti-clockwise. So 180 degrees plus 25.6, we get 205.6. And then the second angle is from the positive x-axis, turning anti-clockwise to here. So we basically have a 360 degrees minus 25.60, and we get 334.40. What about this? Okay, so the third angle will be starting from positive x-axis, then turning anti-clockwise for the second round. So we get 25.60, the 360 degree, okay, one full circle will be 360 degree plus the 205.60 just now. So we get 565.60 degree. Okay. So the angle number 4. Same. We'll turn one full round of 360 degree and second round for the 2x, right? So we have 720 minus 25.60, which is 694.4. So this is the angles for 2x. We want the angle for x. Therefore, 205.60 divided by 2, we get 102.8, and then 167.20, and 282.80, and 347.20. Okay. B. Second of 2x plus 40 equals to 2. Second of 2x plus 40, we can change it into 1 over cosine 2x plus 40. It will be equals to 2. We want the function of cosine, so we switch place of the 2 and cosine 2x plus 40. So cosine 2x plus 40 is 1 over 2. Then the reference angle for 2x plus 40 will be 60 degrees. Okay, because of the arc cosine of 1 over 2. Alright, so because of the positive values here, we know cosine will be positive in quadrant number 1 and quadrant number 4. Therefore, we put the reference angle in quadrant 1 and quadrant 4. So, the first angle will be 60. Second angle will be 300. Alright, but our x is from 0 to 360 degrees. We are talking about 2x plus 40. Therefore, we need to check for the domain of 2x plus 40. Alright, so first, this x will times 2 and then plus 40. So as the 0. 0 times 2, we get 0 plus 40. Therefore, we start from 40 degrees. And 360 degrees times 2, we get 720 plus 40. Therefore, we get 760. Okay. So now our 2x plus 40 is actually equals to 60 degrees. Alright, because our domain is from 40 degree. Okay, so we'll start here and turning 2 round. Alright, so we have 60 degree because the first angle is inside our domain. Okay, and the 300 degree also in our domain. Okay. Then the first angle plus 360 degree for the second round become 420. Okay, and 300 plus another 360 degree, we get 660 degree. So you will check all these angles are in your domain of 2x plus 40. So if I want the value for 2x, so each of the angle should minus 40. Okay, so we get 20 degree, 260 degree, 380 degree, and 620 degree. That is the angle for 2x. We want the angle for x. So each of the angle need to divide by 2. So we get 10, 130, 190, and 310. C. Cotangent x over 3 equals to 0.4452. So cotangent is 1 over tangent x over 3, which is equal to 0.4452. Same thing. If we need to find the value of tangent x over 3, we need to shift it up. So we'll shift this to the right and change place with the 0.4452. So we get 1 over 0.4452, which is 2.246. So tangent x over 3 is 2.246. So the reference angle for x over 3 is arctangent of 2.246, where we get 66 degree. Alright, so 66 degree will be cotangent will be positive, okay, in quadrant 1 and quadrant 3. Therefore, we put our reference angle of 66 degree in quadrant 1 and quadrant 3. Then, check the domain. Our x is from 0 to 360 degree. Therefore, the domain for x over 3 is from 0 to 360 degree divided by 3, we get 120. So, this angle in quadrant 3 is out of our range. So, we can ignore this. Alright, we only focus on 66 degree. Alright, so x over 3 is equals to 66 degree. So 1x means that 3 times 66 degree, and we get 198 degree. Number 5. 5 tangent x equals to 7 sine x. So we have two different functions, tangent x and sine x. And we know tangent x is sine x over cosine x. So we can change the tangent x into sine x cosine x. So 5 times of sine x over cosine x equals to 7 times of cosine x. Sorry, 7 times of sine x. So to make everything in one line, I times cosine on both sides. Right? So we'll get 5 sine x equals to 7 sine x cos x. And then I move everything to one side and factorize out the common factor. Okay, so we can see common factor is sine x, and in the bracket we have 7 cosine x minus 5. Right? So the first factor equals to 0. We get x equals to 0 degree, 180 degree, and 360 degree. This we can get from the graph easily. When sine x equals to 0, these are the highlighted point where the angle is 360 degree, 180 degree, and 0. Alright? Then, for the second factor equals to 0, which we get cosine x equals to 5 over 7. So get the reference angle, 44.42, and put the reference angle into the quadrant so that cosine x will be positive. So, we put 44.42 in quadrant A, quadrant 1, and quadrant 4. And the angle will be, start counting from positive x-axis, anti-clockwise, we get 44.42, and positive x-axis, anti-clockwise to here. So we have 360 degree minus 44.42, which is 315.58. So these are the x values that we get from the solution. Therefore, combine all the 5 angles and arrange it in ascending order. So these are the angles that we get. Question number 1E. Sine square x minus 2 sine x equals to cosine 2x. We see two different functions here, alright? Sine x and cosine 2x. And we know cosine 2x, we can expand the double angle formula, okay, in terms of sine, right? So we change the cosine 2x into 1 minus 2 sine square x. So everything on the left just write back. We have sine square x minus 2 sine x equals to 1 minus 2 sine square x, which is changed by cosine 2x. And then rearrange the equation. We will get this quadratic equation. Rearrange it, we get 3 sine square x minus 2 sine x minus 1 equals to 0. And factorize our equation. We have 3 sine x times sine x. And then the product of the root will be negative 1. So we try to put 1 and 1. 3 times 1, we will get 3. Okay. And then 1 times of sine x, we get 1 sine x. So 3 sine x and 1 sine x to form a negative 2 sine x, we need negative 3 plus 1. Alright. Therefore, we have 3 sine x plus 1 times sine x minus 1 equals to 0. There we get sine x equals to negative 1 over 3. And second factor, sine x minus 1 equals to 0. There we get sine x equals to 1. So from the sine x equals to negative 1 over 3, get the reference angle, we get 19.47. Put the reference angle of 19.47 into quadrant 3 and quadrant 4 so that sine x will be a negative values. Alright, so we have these two angles. From the sine x equals to negative 1 over 3, we can get the x is in third quadrant, which is 180 plus 19.47. We get 199.47. And 360 degree minus 19.47, we get 340.53 degree. Then for sine x equals to 1, we can get it from the graph of sine x. When the 1 here, it is 90 degree. So we know sine x equals to 1, our x will be 90 degree. Therefore, we have 3 solutions for this question, 1, 2, and 3. We arrange it in ascending order. So x equals to 90 degree, 199.47 degree, and 340.53 degree. F. Sine x plus 30 degree equals to cosine x plus 120 degree. So both involve addition formulae. So we expand both sides with addition formulae. Sine x plus 30 degree, we can expand it with sine x cosine 30 degree plus cos x sine 30 degree. And then the right hand side cosine x plus 120 degree can be expanded by cosine x cosine 120 degree minus sine x sine 120 degree. Then we can change all this into values. Alright. So cosine 30 degree will be sine 3 over 2 times with sine x. Sine 30 degree will be 1 over 2 times with cosine x. Then cosine of 120 degree, which is negative 1 over 2 times with cosine x minus sine 120 degree is sine 3 over 2. So sine 3 over 2 times with sine x. And then gather all the sine x on the left and all the cosine x to the right. So we have sine 3 over 2 sine x plus sine 3 over 2 sine x So we'll get 3 sine x equals to the negative 1 over 2 cosine x minus 1 over 2 cosine x. We'll get negative cosine x. And two different functions here, we want to make it into one function so that easier for us to find the value of x. Therefore, we know sine over cosine will be tangent. Alright, so we move the cosine to the left to be divide. So after we divide cosine for two sides, okay, so this on the right hand side will become negative 1. Alright, and the third 3 on the left will be moved to the right, become divide. There we have tangent x equals to negative 1 over third 3, which is the reference angle for arctangent equals to 1 over third 3. We'll get 30 degree. And the reference angle will put in second quadrant and fourth quadrant so that the tangent x will be negative. So for the first angle here, angle starting from the positive x-axis turning here, we'll get 150 degree. And the last quadrant starting from the positive x-axis turn this way, we have 360 degree minus 30 degree, and we get 330 degrees. G. 7 sine x plus 3 cosine 2x equals to 0. So we have two different functions of sine x and cosine x. Cosine 2x. So we can express the cosine 2x into sine x. Right? So 7 sine x remain. 3 cosine 2x will be changed to 1 minus 2 sine square x. So that everything here is in one unknown, which is sine x. And then expand and rearrange the quadratic function. We get negative 6 sine square x plus 7 sine x plus 3 equals to 0. So I prefer to factorize with the positive a. So everything times negative 1. We get 6 sine square x minus 7 sine x minus 3 equals to 0. So factorize it. We get 3 sine x plus 1 times with 2 sine x minus 3 equals to 0. And the first factor equals to 0. Second factor equals to 0. We'll get sine x equals to negative 1 over 3 or sine x equals to 3 over 2. So from the sine x equals to negative 1 over 3, the reference angle will be 19.47. And the 19.47 will be put in quadrant 3 and quadrant 4, so that we get the angle x equals to 199.47 and 340.53 degree. For the sine x equals to 3 over 2, from the graph of sine x, alright, our maximum value is only 1. 3 over 2 is above 1. And we see no intersection of y equals to 3 over 2 and y equals to sine x. Right? Therefore, we have no solution for sine x equals to 3 over 2. Excuse me. Therefore, we have only two answers, which is 199.47 and 340.53 degree. H, sine x equals to 3 sine 2x. The two angles are different, right? So, we expand the sine double angle. So, from sine 2a, we know that is 2 sine a cos a. 2 sine x cos x. And then, times with the 3 in front, we get 6 sine x cos x on the right equals to sine x. Even though we have two common factors here, we cannot straight away cut off. Alright? We need to gather everything to the right and do factorization so that the unknown will also form a factor. Alright? So sine x equals to 0. We'll get x equals to 0 degree, 180 degree, and 360 degree. For the 6 cosine x minus 1 equals to 0, cosine x will be 1 over 6. And the reference angle will be 80.41 degree. So reference angle will put in the quadrant 1 and quadrant 4 because cosine x is positive 1 over 6. Therefore, our x is 80.41 degree and 360 degree minus 80.41, we get 279.59 degree. So 5 of this solution arranged in ascending order. We get x equals to 0 degree, 80.41 degree, 180 degree, 279.59 degree, and 360 degree. I. Cosine x minus 60 degree equals to 3 times of cosine x plus 60 degree. These two angles are different, alright? Therefore, we need to expand them with addition formulae. So, cosine x minus 60 degree will be cosine x cosine 60 plus sine x sine 60. And then 3 times of cosine x plus 60 degree. Cosine x cosine 60 degree minus sine x sine 60 degree. And then simplify the equation. Alright? So we will get 4 times of sine x sine 60 degree. 1 from here. And then negative 3. Move to the left, become positive 3. To plus with the 1. We get 4 times of sine x sine 60 degree. And for the cosine x cosine 60 degree, we have 3 times here on the right and 1 times to be minus. So we get 2 times of cosine x cosine 60 degree. Then change all the values that we can. Okay, sine 60 degree is 3 over 2. Cosine 60 degree is 1 over 2. Simplify it, cut off the 2 and 4. So we left 2 sine x 3 equals to 1 cosine x. Alright, so same thing when we have sine and cosine, we can always divide cosine on the 2 sides. Okay, so that I have sine x over cosine x. Okay, and then the number on the right, okay, should be 1 over the 2 and 3. So 1 over 2 3. So sine x over cosine x, we get tangent x. Okay, therefore we get tangent x is 1 over 2 3. So the corresponding reference angle will be 16.10. So put into the quadrant, we put 16.10 in quadrant 1 and quadrant 3 because of the positive values of tangent x. So we know x will be 16.10 degree and 196.10 degree. Question number 2. Find all the angles between 0 and 2 pi that satisfy the following equations. From 0 to 2 pi means that our x angle should be in radian, in the unit of radian. Alright? So A, sine 2x plus pi over 6 equals to negative 3 over 2. The reference angle for the 2x plus pi over 6 is pi over 3, which is 60 degree. Alright? So, we put the pi over 3 in quadrant 3 and quadrant 4 so that the sine of this angle will be negative. Alright? Then, because of the 2x plus pi over 6 here, we need to find the domain for our solution, which is 2x plus pi over 6. From the x given, from 0 to 2 pi, 2x will be from 0 to 4 pi. Therefore, 2x plus pi over 6 will be 0 plus pi over 6, which is from pi over 6 to 4 pi plus pi over 6. Then we can find all our angles for 2x plus pi over 6 in quadrant number 3, which is pi, plus pi over 3. There we get 4 pi over 3. And this is 2 pi minus pi over 3. There we get 5 pi over 3. Okay, and we have some more. Because of the 2x, we need to turn one more round. So we add another 2 pi for each. There we get 10 pi over 3 and 11 pi over 3. Alright, so now we want the solution for x. So first thing, we try to move away the pi over 6, become minus from each of this angle. We see 2x equals to 7 pi over 6 and 3 pi over 2, 19 pi over 6 and 7 pi over 2. We want the solution for 1x, therefore each single angles divided by 2. So we get 7 pi over 12, 3 pi over 4, 19 pi over 12 and 7 pi over 4. B. 3 sine y equals to 2 tangent y. So we have sine y and tangent y. So the only common things is from tangent. Tangent can be changed to sine y over cosine y. Alright, and we don't like the infraction, therefore we times cosine y on both sides. Alright, so that we have 3 sine y cos y equals to 2 sine y. And then we make everything to the left so that equals to 0. Factorize up the common factor of sine y. We get 3 cosine y minus 2. So sine y equals to 0. We'll get y equals to 0, pi and 2 pi, which is 0, 180 and 360 degree. Right? Then for cosine y equals to 2 over 3, we will get our y in 0.8411 radian. Alright, this is our reference angle. And this reference angle will be put in quadrant 1 and quadrant 4. So that we get our y equals to 0.8411 radian and 2 pi minus 0.8411, we get 5.443 radian. Therefore, put all this into one line. Alright, we get our y in 0, 0.8411, the pi, which is 3.142, and then 5.443, and 2 pi, which is 6.284. All these are in radian. Of course, you can give your answer as in your textbook by changing all this in terms of pi. So we get y equals to 0 pi or 0, okay, and I divide pi here so that I get 0.2677 pi. 3.142 divide 3.142, we get 1 pi. 5.443, alright, divide 3.142, we get 1.732 pi. 6.284 divided by 3.142, we get 2 pi. C. 3 cotangent square of z minus 5 cosecant z plus 1 equals to 0. So, from the cotangent square and the cosecant square, we can change the cotangent into cos square over sine square z. And then cosecant z is 5 over sine z. So we get this equation. And then to make the same denominator of sine square z, we times every terms here in sine z. So we have 3 cosine square of z minus 5 sine z plus sine square of z equals to 0. And we have two different functions, which is cosine z and sine z. Alright, so cosine square of z we can express in 1 minus sine square of z. Then we will have only single function of sine z. So after simplify everything, we get 2 sine square z plus 5 sine z minus 3 equals to 0. Then factorize, we get sine z equals to 1 over 2 or sine z equals to negative 3. So for sine z equals to -3, we have no solution. But for sine z equals to 1 over 2, we will get our z reference angle in pi over 6, which is 30 degrees. So the pi over 6 will be placed in quadrant number 1 and quadrant number 2, so that we get our sine z equals to positive 1 over 2. So the first answer is pi over 6, and the second answer will be pi minus pi over 6, which is 5 pi over 6. D. Sine 2a minus cosine 2a. So because of the same angle, we move the cosine 2a to the right, and we divide cosine 2a on both sides. So sine 2a divided by cosine 2a, and cosine 2a divided by cosine 2a will get 1. So sine 2a over cosine 2a, we get tangent 2a equals to 1. Therefore, the reference angle of 2a will be pi over 4, which is 45 degrees. And this reference angle will be placed in quadrant number 1 and quadrant number 3 to get a positive values for tangent 2a. Then, because of the 2a, we need to check the domain for 2a. Domain for a is from 0 to 2 pi. Therefore, 2a will be from 0 to 4 pi. So, the first angle, we have pi over 4. Second angle, we have pi plus pi over 4, which is 5 pi over 4. And then third angle, which is pi over 4 plus another 360 degrees, or plus another 2 pi. And we get 9 pi over 4. And the last angle will be from 5 pi over 4 plus another 2 pi. So we get 13 pi over 4. This is the angles for 2a's. We want the angle for a. So each of this angle will be divided by 2. There we get a equals to pi over 8, 5 pi over 8, 9 pi over 8, and 13 pi over 8. E. Cosine b sine b equals to 1 over 4. We are quite familiar with cosine b sine b. Alright? We know that 2 times of sine b cos b, alright, is sine 2b. That is the double angle formula for sine. Therefore, on the first line, we times 2 for each side, so that we get 2 sine b cos b. And then 1 over 4 times 2, we get 1 over 2. So now, we have sine 2b equals to 1 over 2. And the reference angle for 2b is 30 degrees, which is pi over 6. So, where do we put our pi over 6? We place the pi over 6 in quadrant number 1 and quadrant number 2. Alright? So the next thing, because of the 2b, we need to check the domain for 2b. Our b is from 0 to 2 pi. Therefore, 2b is from 0 to 4 pi. There we get 2b is actually equals to pi over 6. And then pi minus pi over 6, which is 5 pi over 6. Then second time, or each of this angle plus 2 pi, we get 13 pi over 6 and 17 pi over 6. Therefore, 1b is actually pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. F. 4 sine x minus pi cos minus pi equals to 1. From our double angle formula, we know that 2 sine cos of the same angle will be sine 2 times of the angles, which is x minus pi. So, if we need a 2 here, we divide both sides by 2. So that we get only 2 sine x minus pi cosine x minus pi. n equals to 1 over 2. 2 sine x minus pi, cosine minus pi, we can simplify it by sine 2 times of x minus pi. Therefore, the reference angle for 2 times of x minus pi is actually pi over 6, which is arcsine of 1 over 2. There, we need to put pi over 6 into quadrant 1 and quadrant 2. And check on the domain of x minus pi. From our domain of x from 0 to 2 pi, x minus pi will be 0 minus pi, which is negative pi, and 2 pi minus pi, which is pi. So, we'll start from negative pi to positive pi. And we need to times 2 for this range. So, the 2x minus pi will be from negative 2 pi to positive 2 pi. Alright? So, if it's from negative 2 pi, if this is from negative 2 pi, alright, then we turn anti-clockwise and reach here. So the first angle should be negative 2 pi plus pi over 6. Therefore, we get negative 11 pi over 6. Alright, the first angle. And then, same here. Alright, start turning from the negative 2 pi to here, anti-clockwise, to get the second line. So we get negative 2 pi plus 5 pi over 6. There we get negative 7 pi over 6. So we get the second angle. And then the coming angle will be the first angle plus 2 pi, which is negative 11 pi over 6 plus 2 pi, and we get pi over 6. And negative 7 pi over 6 plus 2 pi, we get 5 pi over 6. This is the angle for 2x minus pi. So, if we divide everything by 2, we'll get the x minus pi equals to negative 11 pi divided by 12, negative 7 pi divided by 12, pi divided by 12, and 5 pi divided by 12. And we want x. Therefore, we move the negative pi to the right hand side for each. We plus pi for each of this angle. We get pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. So all this x is between 0 to 2 pi. And this answer is different from your textbook, where he gave like 25 pi over 12 and 29 pi over 12, which these two are out of our domain. Therefore, the correct answer should be x equals to pi over 12, 5 pi over 12, and 13 pi over 12, and 17 pi over 12. Thank you.